All right, everybody, welcome back. You guys asked for it, so I'm going to give it to you. This is 10.3 Quadratic Transformations. Again, my name is Mr. Martin. This is Mr. Martin's Math Corner. What we're going to do in this section is we are going to identify what we call transformations from the parent function. So I'm going to talk a little bit about what our parent function is of a quadratic. And then we're going to be able to also write a quadratic in vertex form if I give you a description of transformation. So it's one thing to tell you what to transform and how to graph it, but it's also important that we can look at a graph and understand the transformations that it went through. So without further ado, we have our things to know. So the parent function of a quadratic is as follows, and we have f of x equals x squared. So now what this parent function means, okay, I like to call this our most basic quadratic function, meaning there are no transformations that have occurred. This is down to its core, the most simplest of all. Okay, and then what a transformation is of a quadratic, this describes the shift, reflection, and shape change of a quadratic when compared to the parent function. Okay, so this right now is in standard form, but we can also write the parent function in vertex form. And the reason why I want to show you that is because when I pull up Desmos, we play around with some graphs for a little bit, you're going to wonder why I typed it in the way that I did. So if we look at this in standard form, what is our a value? Right now we have an a value of 1. So if we were in vertex form, we would have nothing on the outside there, indicating that it is a value of 1. And then remember, we always have this parenthesis, we always have this x, but if I did not move anywhere, I'm going to have this 0 here, my squared exponent would be there, and then I would also be plus 0. So this is what our parent function looks like in vertex form. This is what it looks like in standard form. Alright, so let me go ahead and jump into Desmos because I want you guys to see how these actually are the same on the graph. Alright, let me pull this up. Okay, so if you can see here right now, I have the vertex form. I'm on this blue graph. I also typed in the function here on the red line. So if you see, if I click on here, it's exactly the same graph. Okay, so this lets you know that I wasn't lying. X squared is the same as this x minus 0 squared plus 0. Okay, I want to move this down a little bit. Let me zoom this out, or zoom it in rather, so you can see the ones. So remember, we did that 1, 3, 5 method where I talked about if we're graphing and we had an a value of 1. And let's see if that works here. If we go over 1 and then up 1, that's our 1, 3, 5, we get a point right there. Over 1, we should be going up 3, and that hits right there. And then over 1, and if we go up 5 here to 9, you should see a point right there also. If I can click on it. Oh, you get the picture. Rather close. There we go. Boom. 3, 9. Okay. So this right now means we have done no changes to this graph whatsoever. Okay. All right. So I'm going to hop back now to our notes. Okay. And as you can see here, I have some graphics for you. The first thing that we're talking about is our horizontal translations and our vertical translations. And the horizontal translations, if you look at the image, this is merely saying that we have the same graph. None of the shape or direction has changed. We just simply either move to the left or to the right. Okay, but the one thing that I want to also share with you, let me pop this up here. All right, there we go. So anytime that we are in vertex form and we're dealing with any of our translation values inside the parentheses of that vertex form, I always want you to think the opposite. Okay, remember, if we have a negative number, and we talked about this when we discussed the vertex, the values of the vertex from vertex form, if we had a negative number, we ended up seeing that shift to the right. Okay, if we had a positive number, we had that shift to the left. And then when we have a vertical translation, that k value of our vertex, I mentioned that always think true, it is as is. All right, so let's play around with a couple of horizontal translations and vertical translations here in Desmos. Alright, so I'm going to get rid of this red line because we want to work with Vertex Form. Okay, so I'm going to copy this. We're going to do a second line here in green. Okay, let's go ahead and change this value to CA horizontal. So if I'm keeping that negative sign, I should be moving to the right because we are thinking the opposite. So you guys see now, if I had a -5, that means I am moving to the right. You would think to the left because it's negative, but I'm reminding you, always think the opposite. And now let's try if we had a +5. Okay, and then you can see how this moved to the left. So our graph shape, values, as far as the 1, 3, 5, that has not changed. All that has changed is that our x values of our vertex have changed. So if you look at your y values, these are all still zeros, but it is the x value that has changed. So that is what our horizontal shift looks like. Okay, let's go ahead and put these back at 0, but play around with the k value, which is our vertical, so our up or down shift. So if I change this to a 2, notice how we still have a over 1, over 1, up 3. But what happened was the vertex shifted up 2. Okay, so we kept the same x value, but our y value is what has changed. So let's try a, you guessed it, -2. And then if we move this graph down, we can see that we vertically shifted down by 2 units. Okay, so that is what our horizontal and vertical translations look like. All right, let's move on to the next graphic. Okay, so on this one we have what we call the reflections, and one is going to be with the x-axis, one is going to be with the y-axis. This one here with the y-axis, let me jump to this one first. This one you don't really notice much of a change because you're kind of just flipping it around that y-axis, and since we have a vertical parabola, we are not seeing much of a change there. Okay, the one that we are going to mainly focus on is this reflection in the x-axis. Okay, and that means when we have a -a value, that's what changes us from that positive parabola to that negative parabola. So instead of opening upward, we are going to be opening downward. So let's take a look at what that looks like in Desmos. Okay, so here, let me change these back to zeros. Okay, so if we are working with the blue line, okay, this is our parent function. Let's go ahead and add a -a value. Okay, so if you look, our parabolas look the same. They are identical. All that happened was we went from a positive parabola to a negative parabola. So that negative on the outside is going to indicate if you have a reflection. Okay? All right, and then our final one, which are probably the more difficult of the translations. All right, we have what we call a horizontal stretch and shrink and a vertical stretch and shrink. Okay, so these ones do take a little bit of time to play around with, and I would like you to take this part down in your notes because sometimes when you look at different resources, you're going to see different terminology used for that word shrink. So you might see the word shrink, or you might see the word compression. Okay, and then there is this other video that I'm going to share with you guys from the people over at Math is Power for You, and I believe they use the word compression, but these graphics that I have here for you use the word shrink, but they are exactly the same thing. Okay, when we talk about a horizontal stretch or shrink, okay, the main thing that I want to remind you of is that we have a translation value that is placed inside the parentheses of your vertex form. Okay, so if you notice here from the parent function x squared, we ended up having some kind of value in front of the x, but this is locked in inside the parentheses. But with the vertical, we have the x squared parent function, but instead this value is on the outside. So if this were in vertex form here, it would look something like this, where we would have that value, okay, on the outside, indicating whether or not we have a vertical stretch or shrink. Okay, so just remember, outside, vertical, inside, horizontal. And again, I would like to remind you that anytime we deal with the values on the inside of the parentheses, I always want you to think the opposite or the reciprocal. Because remember, the reciprocal, right, if we had some value 2, the reciprocal of 2 would be 1/2. And you guys are going to see why that is a big deal when we work with the horizontal stretch or shrink. All right, so let me go ahead and put this part up in the notes for you just so you can remember. All right, so remember, think the opposite or the reciprocal if we are dealing with values. And then for this one with the vertical, it is true as is. Okay, and then in that video that I'm sharing with you guys from the people over at Math is Power for You, they put a really good emphasis on whether or not it is the X or the Y values that are changing. One will stay the same while the other changes when you have that shrink or compression based on where you are stretching or shrinking away from. So if we look at the horizontal stretch, okay, this indicates that we are stretching away from the y-axis. Okay, I know these graphics look very, very eerily similar, but they are very much indeed different. Okay, when we have a vertical stretch or shrink, we are stretching or shrinking away from the x-axis. Okay, so once we play around with these a little bit, you are going to see how that works. So let's go ahead and pull up Desmos. Okay. All right, so I got Desmos up here for you, and we have our parent function here in blue. Okay, remember, over 1, up 1. If I can find it. Let's click on the side. 1, 1, and then over 1, up 3. Right? Okay. This green one and this purple one, these are going to be describing our horizontal stretch or shrink. Now remember, when we are dealing with the horizontal, we are inside that parentheses. Let me pull it back to here. Remember, this is our value that is inside the parentheses. So we want to think the opposite as far as whether it is a stretch or shrink. And then we also want to think the reciprocal based on whatever value we have. So this is where it is our x values that are changing, but our y values are staying the same because we are dealing with moving away or towards that y-axis. All right, so if we look, if I have a value of greater than 1, okay, this is indicating that I am shrinking towards the x-axis, because if I have this blue line, okay, my green line is now moving closer to the y-axis, so that means I am shrinking in. Now granted, a larger number you would think a stretch, but remember, in the horizontal we are thinking the opposite. So if we look, our original was up, our parent function originally was over 1 and up 1. Okay, we do have a point at 1 right here. Okay, but what ended up changing was, instead of going to the right 1, which is our x value, we went to the right by 0.5. Okay, and 0.5 is half of 1. And what is the reciprocal of 2? 2 over 1. Reciprocal is 1/2. Okay, now if we went over 1/2 again, we should be going up 3 because that's the original y, and we would go 1, 2, and 3. Okay, so you can see that it is our y values that are remaining the same. It is our x values that are shrunk by 1/2 when we have a value greater than 1. Now if we look at the purple graph, we have a value of 1/2, but we are thinking the reciprocal and we are thinking the opposite of shrink. So this one is stretching away from the y-axis, so it's now to the right of the parent function, and it is still our x values that are changing. We are just stretching, okay, by a value of 2 because we are doing the reciprocal of this 1/2. So if our x value changes to 2 instead of over 1, notice how when we go to the right 2, we go up 1. We go to the right 2, and then we go up 3. Okay, So always think the opposite and then do the reciprocal of that value. So anytime you see a value of 2, we are shrinking by 1/2. If we see something like 1/2, we are stretching by 2. I know, very confusing. All right, let's go to the vertical ones. Those ones are a little bit easier. All right, so here in the vertical, notice how when we are greater than 1, we are a stretch, as opposed to greater than 1 was a shrink. This is the one where it stays true. So if the number is bigger, you're stretching. If the number is smaller, you're shrinking. So I recommend mastering the vertical stretch and shrink so you really have an understanding of this, and then you can easily think, oh, horizontal, I just got to make sure that I do the opposite. All right, so let's see how this works in Desmos. All right, so I got Desmos here. The blue, again, is our parent function. The green is going to be my stretch, okay, because now I am stretching away from the x-axis. So if you see our blue parent function, notice how the green is going away from this x-axis, okay? And if we do our normal 1, 3, 5, notice how we are changing. So instead of going to the right 1 and up 1 to get to the green line, I must go up 2. So over 1 and then up 2. Okay? When we have the shrink or compression, which is this 1/2, you notice how it is shrinking or compressing towards the x-axis. So if we now go over 1, we are going up 0.5. Okay, so that is our vertical stretch or shrink. And when you see the values in a table, which is in that video that I'm going to share from the Math is Power for you guys will really see how here with the vertical, it is our x values that are staying the same, and it is our y values that are changing. Alright, so let's go through a couple of these problems. Here in example 1, it wants us to describe the transformation from our parent function, f of x equals x squared, and then we want to graph each function. Now remember, I want to remind you, if your parent function is x squared, the way that looks in vertex form is that x minus 0 squared and then a plus 0. So if we look at this first one, it does not look like it's in vertex form, but how can we get just that x squared? Okay, and that would be by doing x minus 0, because this right here would turn into x squared. So if we don't have a horizontal shift, okay, then that just means we have that x squared. So looking at this first one, this indicates we do not have a horizontal shift. But if we had something on the outside, if this was that minus 3 like we have here, right? How would this look simplified? Well, we would do f of x equals, this gives us x squared, then we would drop that down and we would have minus 3. So this one just lets us know there is no horizontal shift, but we indeed do have something going on over here. So let's go through each of these parts first. So with the reflection, we want to look, do we have an a value that is negative? So in this case, it is a positive, so reflection over the x-axis is none. Okay, there is no negative sign out there. Okay, then we want to look at our a value. The first thing that I look for vertical is, do I have any value greater than 1 or less than 1 in front of my x squared on the outside? This one looks like it is only a 1, so this tells me there is no vertical stretch or compression. Okay, now with the horizontal stretch or compression, I would need to see something inside of that parentheses, like we would have in this example here. There's a set of parentheses in vertex form. This one, if there is no parentheses there, most likely indicative of no horizontal stretch or compression. So we're going to put none right here. Okay, and then do we have a vertical shift? Yes, we have a vertical shift right here. So what is the shift that's happening? We are going down 3 units. Okay, and then we said there was no value going on inside of that parentheses because that's what gave us our x squared. So we have no horizontal shift. Okay, and if we have no horizontal shift, we know that we have an x value of 0, right? And then we have our vertical shift up or down. This gives us the y value of our vertex, so that is really easy to see as -3. All right, so let's go ahead and graph this. All right, looks pretty good. So all I did was shift my graph down by 3 units. All right, let's take a look at the next one. Do we have a negative sign out front? We do not, so there is no reflection here. We have an A value on the outside of 1, so there is no stretch or compression. So we have none for vertical. Do we have a value in front of the X inside the parentheses? We do not, so there is no horizontal stretch or compression. Okay, do we have a vertical shift? Is there a plus or minus some value over here? No, we do not, so there is no vertical shift. And do we have a plus or minus value after the X? Inside the parentheses we do. We have a +2. So remember, we are in that parentheses. We want to think the opposite. So we are going to shift left 2 units. Okay, and then our vertex, right? If this is +2, we are doing the opposite in our vertex, and we have no vertical change, so that means we have a y value of 0. All right, let's go ahead and graph this. All right, looks good. So remember, my vertex is -2, 0. I put that there because we only had that horizontal shift of going left 2 units. All right, very good. So we got 2 more down here. I'd like you to pause the video before I jump into these. Try them on your own, see what you can get, and then come on back. All right, welcome back. So I'm going to run through these with you guys. Hopefully you put down what I'm about to put down. So do we have a reflection? No negative sign, so this is a none. Do we have a vertical stretch compression? We do have a 2 on the outside. So this is actually a vertical stretch. Remember, when it's vertical, we always think as is. If it's a bigger number, it's a stretch. If it's a smaller number, it's a compression. So we have a vertical stretch of 2. The value is as is. Okay, and then if we look inside, is there a value in front of the X? There is not, so we do not have a horizontal here. Okay, and then vertical shift. Okay, yes, we do have a vertical shift. We have a K value out here, so we're going to go down 7 units. And then do we have a horizontal shift? Yes, we have a +4, so we do the opposite. We are going to go left 4 units. So our vertex should be -4, -7. All right, then let me go ahead and pop that graph up for you. All right, and there it is. So our vertex of -4, -7, and our graph looks like this. Okay, and remember, if you want to fact check it, remember, if you have an A value vertical stretch, remember we should be going over 1, up 2, over 1, and then up 6. Okay, 2, 6, 10, that's your 1, 3, 5. All right, and then our last one here, do we have a reflection? Yes, we do. So I'm going to put yes, we are reflecting over the x-axis. And then vertical stretch or compression, we are smaller than 1, so that is going to be a compression, and that value is of 1/4. Okay, we do not do the reciprocal for the verticals. Do we have a value in front of this A? We do not, so there is no horizontal. Okay, vertical shift, yes, we're going to go up 3 units. And then we have a -2, so we are going to go right 2 units. And then that gives us a vertex of 2, 3. All right, let's go ahead and pop this graph up. All right, so we have our graph here. If you look at that vertex 2, 3, and then we have that 1/4. So if you're going over 1, you should be going down by 1/4, and then over 1 again, down by another 1/4. Okay, so make sure you are using that 1-3-5 method when graphing. All right, let's take a look at our next example. Okay, So here we have the following descriptions of transformations, and we want to be able to write these in vertex form. So this is as simple as always starting with your f of x and your equals, and then we kind of just go across the board. Remember, vertex form looks like this. Let me put this up for you. We have that a value, x minus h squared, and then plus k. Okay, so if this is telling me we have a reflection across the x-axis, we know that we're going to have that negative sign out front. We have a vertical stretch of 2. Okay, so that means I'm going to have that a value of 2 on the outside. I'm going to have my parentheses. If I am shifting to the left 7 units, left or right, remember I got to do the opposite. So left is going to be a positive 7. Okay, and then we are shifting up 4 units, so plus 4. And that is it, my friends. That's how we do those. Okay, so this second one, we now have our infamous difficult one, and I say that mainly just because it was difficult for me when I first learned these. And I like to share that kind of stuff with you guys. Not everything comes naturally easy to myself, so don't feel bad if it takes a while to understand these. Okay, so let's go ahead and start with writing what we know we need to write, f of x and equals. Do we have a reflection? No. So there will be no negative sign. Do we have a vertical stretch of some sort, vertical stretch or compression? No, we do not. Okay, so then that means I can start with my parentheses. Okay, now this tells me I have a horizontal stretch of 3. Okay, so remember, I am always thinking of the opposite and the reciprocal. So I know that I'm going to have a value in front of the x here. Okay, so I can put my x. Okay, but when I'm dealing with a horizontal stretch or compression, when I'm describing this value, it is always the reciprocal of what is seen inside the parentheses here. So the reciprocal of 3, right, if this is 3 over 1, the reciprocal, you know, you're going to flip these, is going to be 1 over 3. So I'm going to have a 1 over 3. Okay, and if we look back, okay, I want to take this back. So if we have 1/3, remember that is a value of less than 1. So if we go back to here, remember when you have a value of less than 1, that is indeed a stretch for a horizontal. Okay, so make sure you keep that in mind. All right, then we have shifted to the right 3 units. Okay, so if we're going left or right, remember we always do the opposite sign of what this word tells us. Right, you would think, would be positive, but here we need to put that opposite sign right there. And then we put our squared exponent, and then we are going down 4 units, so we are going to go minus 4. And that is it. All right, with that being said, I think these are a little bit easier. So I do want you to pause the video here, try these next 2 on your own. All right, welcome back. So this first one here, I got negative and then parentheses 2x minus 4 squared. We got that reflection. Reciprocal of 1/2 is 2 because we're talking about horizontal. And then we shifted to the right 4 units, so I had to put the negative 4 there. Here we got a vertical compression of 1/3, horizontal stretch of 4, so we do that reciprocal. Right 6 units, so I put that minus 6 and then shifted up 5 units for plus 5. All right, very good. And then last but not least, example number 3, where we are looking at the graph and we want to be able to write these in vertex form. Okay, so I will give you a hint on these ones, and I believe on the homework there are no horizontal stretch or shrink. So just think of the vertical ones for these problems. Maybe on the exam, though, I might give you a horizontal, so keep that in mind. Had to sip my drink real quick. All right, so first thing we want to do is we want to find the vertex. Okay. And all of these are at even points. Okay. Let's find this vertex. So my vertex is going to be -2, -4. Okay, and then what I want to do is just instantly start writing my f of x equals, okay, and if I have a positive opening graph, I do not have a negative sign. There is no reflection there. Okay, but I want to first see, do I have a vertical stretch or shrink? So remember, with our 1-3-5 method, we always go to the right one, okay, and then I want to go up until I get to the graph. So if I go up, and with the vertical, I am looking at the change in my y values. So normally I would be going up one and, or I'm sorry, right one and up one if I had a value of 1. But if I only went up by 1/2, okay, so 1 times a equals 1/2, okay, what would be my a value? Well, 1/2 divided by 1, that would give me 1/2, okay. So that means I have a value of 1/2. Okay, then I need to see, did I shift left or right? I sure did, because my vertex is all the way over here. And all we're doing, just like we did in the last section, is doing the opposite of this x value. So if this is -2, we're going to do +2. And then this part is the part that stays true, our k value in our vertex form. Let me go ahead and put that up for you. Remember, it is a times x minus h squared plus k. Get to know it. He's your best friend. And then we're going to put that -4. And we are done. Boom. Look at that. All right, let's do this next one together. We have a vertex of 1, -3. So I know that I can even start filling this out. I could leave a little bit of space here. I know I'm going to have my x and something, and then something here. So let's figure that out. Well, the opposite of this +1 is going to be -1. That -3 is going to be on the outside. Now all I'm really doing is figuring out my a value. So let's take a look. Do we have a positive? We do, so there is no minus sign out front. And I am going over 1, up 1, over 1, up 3. So if my 1-3-5 is indeed 1-3-5, that means we just have this 1 on the outside. That is done. All right, so as you can guess, I got 2 more down here that I would like you to try on your own. Go ahead, pause the video, then come on back. All right, welcome back. So I ended up finding a vertex of -3, 3. And when I tried to figure out my change in y values, if I went over 1 and down 2, that means I have a 1a value of 2. How can I figure out what a is? Well, 2 divided by 1 is 2. So that means I have that 2 right here. I have this negative graph, so I needed to put that minus sign. And then I did the opposite of my x value here, which is +3. And then this one stayed true as +3. So the same thing here. If I went over 1 down 2, that means I have a -2 out front. And then I did the opposite of this -1, +1, and then the 3 rings true. All right, folks, that is all I have for you. Please, please, please watch that additional video that I'm sharing with you guys from Math is Power for You. It is awesome. It is my favorite video of all time, actually. Well, maybe favorite math-related video, but had a blast. Remember, if you got questions, please don't hesitate to reach out. Ask a family member, ask a friend, ask whoever you can. Somebody is willing to help you. I will catch you guys on the next one. This is Mr. Martin and Mr. Martin's Math Corner. Peace.